In this video, I will talk about trigonometric functions of any angle. Specific objectives of this lesson are finding reference angles and then using reference angles to evaluate trigonometric functions. All right, so we know that based on the angle that we have, we might end up at different places on a coordinate plane, like given on the left side of the graph. We know that quadrant 1 is this one, quadrant 2, quadrant 3, and quadrant 4. So say if your angle is in between 0 and pi over 2, which is the same thing as 90 degrees, then you're going to end up being in quadrant 1. And we know that x is always positive, y is always positive. And if we happen to be in quadrant 1, we also need to note that sine is positive, cosine is positive, tangent is positive. If we're on the second quadrant, then we know that our angle is bigger than 90 but smaller than pi over 2, or the opposite, bigger than pi over 2, smaller than pi. We know that x is still positive, x is negative, y is positive, and corresponding trig functions are given on the right side. So based on what our angle is and what quadrant we are, we have different variations, different signs for the functions. So we're going to refer to this a lot when we evaluate our trigonometric functions. So we're going to keep this in mind. So generally, we're interested in angles bigger than 90 degrees, right? So we might have angles that are bigger than 90s, and we might have situations where we might need to evaluate trig functions for angles bigger than 90. So then what we're going to do for that is that we're going to determine values of trig functions from their values at corresponding acute angles called reference angles. So to be able to evaluate functions that have angles that are bigger than 90, we're always going to find their reference angle. So specific definition of a reference angle, it's reference angle is the acute angle theta prime formed by the terminal side of theta and the horizontal axis. So here are examples for that. For quadrant 1, you guys realize we don't need a reference angle because quadrant 1 is already smaller than 90 degrees. So we need reference angles only for quadrant 2, quadrant 3, and quadrant 4. Because if an angle is going to pass through quadrant 4, then it's going to kind of repeat the same behavior, right? Like if we have an angle that goes from here, if it keeps getting bigger and bigger, like repeat the same thing, so we don't really have more spaces to go. So there's only 4 portions that our angles might end up with. So specifically, if our angle is in quadrant 2, the way we're going to know that is because we know that angle must be bigger than pi over 2 and smaller than pi, right? If this is the case, then we're in quadrant 2. And then the way we're going to find our reference angle for that is we're going to subtract that angle from pi. So we're going to do pi minus theta or 180 minus theta, and that'll give us the reference angle. So when we say a reference angle, we really mean this portion, right? So this portion that you see is your reference angle, and we're going to use that to compute trig functions. I'm going to be showing examples of that pretty soon, but that's how it is. So if I know my angle is bigger than pi, but then smaller than 370, 3 pi over 2. If that is the case, then I'm gonna know that my angle must be in quadrant 3. That's how I know it, because my angle is bigger than pi, smaller than 3 pi over 2. And then the way I'm gonna find my reference angle is I'm gonna subtract pi from my angle. So you guys realize it's a little bit different this time. Now, because my angle is bigger than pi, I'm going to subtract pi from my angle. So in this case, my reference angle is really this small acute angle that you can see. So this is my theta prime. and that's what I'm trying to figure out, and I'm going to use that to compute my trigonometric functions. And lastly, if my angle is bigger than, if my angle theta is bigger than 3 pi over 2, bigger than 270, but smaller than 2 pi, which is 360 degrees, then I know for sure my angle is in quadrant 4. So as you can see, this whole thing is my theta, quadrant 4. And then what I'm going to do is I'm going to try to find the reference angle for that. The way I find the reference angle for this case is I just subtract it from 2 pi or 360 degrees to get this acute angle right here. That's going to give me my theta prime. So the way I do that is I subtract my angle from 2 pi. So those are the 3 scenarios that we need to keep in mind when we find reference angles. All right. So now let's move on some examples about this. All right, so the first one that is given is 300 degrees, right? So what I know about 300 degrees is I'm going to first figure out what quadrant is this in? What quadrant is this in? So then I ask the question, well, this is bigger than 90 degrees, bigger than 180, bigger than 270, but it's smaller than 360, right? So then my guess would probably be quadrant 4 because I know that 300 is bigger than 270, but then it's smaller than 360. So it must be quadrant 4. And I know that if my angle is in quadrant 4, the way I'm going to find my reference angle, so reference angle, we know that reference angles for quadrant 4 are found by subtracting the angle from 360. So we need to do 360 minus theta. This is what we're supposed to do. So in our case, what we're going to do is then we're going to subtract 360 minus 300 because that was my angle, and then I'm going to get 60 degrees. So that's going to be my reference angle. Okay? So reference angle for 300 degrees is 60 degrees. So next thing, I'm going to do the same thing for the next angle. So you guys realize this is theta equals 2.3 because there is no that like little oval symbol on it. This means this guy is in radians. So 2.3 radians, right? 2.3 radians. So the question first I ask is what quadrant is this angle in? Okay, well, we're going to think about it, right? So we know that pi is something like 3.14, right? We know that pi is around 3.14. And then that is actually bigger than 2.3, right? Because 2.3 radians is smaller than 3.14 radians. So then my angle must be smaller than pi. And then I need to compute pi over 2. Let's take a look at pi over 2. If 3.14 is pi, then we need to half that. So I think it's going to be like 1.57 something. And I know that 2.3 is bigger than that. So my angle is bigger than pi over 2, but smaller than pi. So what quadrant is this? Quadrant 2, right? Quadrant 2. Okay, so if we know our angles are quadrant 2, how do we find reference angles? Well, I need to subtract my angle from pi. So that's the way I will do it. So then I'm going to do pi minus my angle, 2.3. So the way I'm going to compute that, you can use 3.14 if you like to. We don't have to be super accurate. So I'm going to modify this a little bit. So approximately pi minus 2.3 must be 314 minus 2.3. And what's that going to be? Let's compute that very quick. So I actually have the answer very quick, 0.84. So then what that is that when we subtract 2.3 from 3.14, we get 0.84. So that must be the reference angle for 2.3 radians. Okay, so lastly, part C, I'm going to do a similar work. this is a little bit tricky because it's a negative direction. So let's try to draw and figure out where this angle goes. So because we're at negative, we're going negative 135. So we're going to do, so this is negative 90 degrees, 180. Do I need to go that far? Probably not. I need to back up a little bit. So I must be somewhere around here, right? I must be somewhere around here. So this must be negative 135. Okay, so then what I need to do is I need to figure out what quadrant I'm at. So you guys realize based on my picture, I know that I'm at quadrant 3. The way I find reference angles in quadrant 3 is I need to subtract. There's multiple ways in this case, but I need to subtract my angle. I need to subtract 180 from my angle. So what I'm basically trying to figure out is what is this little angle that you see? You guys see that? I need to find this little angle. So by thinking, you may realize, well, I know that 135 plus 45 is 180. Then you may say, well, that angle must be 45 degrees. So you can say, well, reference angle for this guy is going to be 45 because I know that negative 135 has that little angle, purple angle given, and that little angle must be 45 because that's how you make one whole angle. Another way of doing it is you may figure out the coterminal for negative 135. So coterminal for negative 135 degrees would be something like coming from the positive direction, right? So like we can find this whole blue angle. The way I can find that is I subtract that guy, negative 135, from 360, and that gives me something like 225, I think, 225 degrees. So that blue one must be 225 degrees. Because I still need that purple area, then what I'll do is I'll subtract 180 from that 225 minus 180, and that should give me 45 degrees. So that's another way I can find that purple region. So yeah, for negative 135, then I must have 45 degrees as a reference angle. And I have, a slightly different solution for each of this that you can take a look. And then next thing I'm going to do is now I'm going to show you actually how to use these reference angles to evaluate trig functions. Okay, so we're going to actually do it by hand. But before doing that, I'm going to refer you guys to these common values that we learned on a unit circle, right? So like we have different values for sine, cosine, tangent based on the given angle. So time to time, we might need to reference this. So I'm keeping that in this slide. All right, so here's what we're gonna do. Now we're gonna use reference angles to evaluate each of these given functions. All right, so first we're gonna start with cosine of 4 pi over 3. Next, we're gonna do tangent of negative 210, and then cosecant 11 pi over 4. So what we're gonna do for each of these guys is first we're gonna find what quadrant they are, what quadrant the angle is. Second, we're gonna find the reference angle, and then lastly, evaluate the function. So these are kind of my steps. Okay. All right. So for the first one, we know that the given angle is 4 pi over 3. So I know that 4 pi over 3 is gonna be bigger than 180. And so what that is my angle then must be somewhere in the quadrant 3 because it's bigger than a pi, but it's smaller than, let me write it here, 4 pi over 3 I know is bigger than a pi, and it's smaller than 3 pi over 4, 3 pi over 2, because that's 270 degrees. Okay, so we learned about that. You may be asking, well, what's the best way of doing it? In my head, what I do is like, okay, well, this is 4 times pi over 3. And then I ask, well, what's pi over 3? So that's 60 degrees, right? So I'll say, well, then that must be 4 times 60 degrees, which is something like 240 degrees. And I'm like, 240 is bigger than 180, but it's smaller than 270, right? This guy is smaller than 270. So that's how I know it. People have different ways of looking at it, but that's how I know it. All right, so now we know that this guy is in quadrant 3, and let's find a reference angle. So the way we find reference angles when we're in quadrant 3, we subtract pi from our angle. So I need to subtract pi from my given angle, and then that ends up being pi over 3. So that is my reference angle. So what do I do with this reference angle? I need to compute my cosine, right? My purpose is to compute cosine 4 pi over 3. So the way I'm going to do that is I'm going to find cosine of pi over 3 instead, because I don't need to know what 4 pi over 3 is, because I don't have a way of knowing it. The way I can know it is because I know cosine pi over 3. And the value for that, we can go back to this table. Cosine pi over 3 is 60 degrees, right? So then cosine 60 must be 1 over 2. So I'm going to use that. But one thing I have to keep in mind is that is cosine positive or negative at my quadrant? So then because we're at quadrant 3, cosine is always negative, right? Cosine is negative in quadrant 3. So for that reason, we have to add this negative piece to it. So what we're going to say then cosine 4 pi over 3, the value of this guy, which is what we eventually wanted to find, is always going to be negative 1 over 2. All right, so for the next example, which is tangent negative 210, I recommend you pause the video and then try for yourself and then see or listen the solution if you need to. Please pause the video and try it for yourself. All right, hopefully you had a chance to try it for yourself. So I'm going to go ahead and solve this one as well. So because I know that graphically negative 210 is going to be somewhere bigger than 180, and that means that we're in quadrant 2. Okay, quadrant 2. And the reference angle for that is that blue area, this little angle we see right here. And the way I can find that is I know for sure that the coterminal for this guy, so like the other side of this angle, is something like 360 minus 210, which is what, 150. So this guy must be 150 degrees. So then the way I can find that little area is I will subtract 150 from 180 and then get 30 degrees. So that little area must be 30 degrees. So that's my reference angle. Okay, so then next thing I'm going to do is now I have my reference angle, but I need to find tangent of negative 210, right? So that is going to be a question. So the question we're going to answer is negative tangent negative 210 is going to be equal to tangent 30, but I don't know if the positive negative situation, like how that situation works. So let's think about it. Is tangent positive or negative in the second quadrant? So because I know tangent is equal to sine over cosine, because we know that tangent is sine over cosine, and sine in the second quadrant is positive, but cosine is negative. For that reason, tangent must be negative. So what we're going to say is then, well, tangent of negative 210 must be equal to negative of tangent 30. So let's figure out what tangent 30 is. I'm going to go to my table. Tangent at 30 seems to be square root of 3 over 3. Then this guy must be negative square root of 3 over 3. That must be my answer. Last example we're given is cosecant 11 pi over 4. If you like to take a look at it for yourself and try it, that would be great. Pause the video, try it for yourself. So finally, in order to figure this one out, we're going to consider what 11 pi over 4 is. That's a big angle. We know that 11 pi over 4 is definitely bigger than So we consider 11 pi over 4 to be a really big angle because we know that it is for sure bigger than 2 pi. In fact, it's bigger than 2 pi added pi over 2 as well, right? But then it is smaller than 2 pi plus pi, right? So then what that means is that my angle must be at the second quadrant. So it does like one full cycle. So you guys realize this is one full cycle. This is 2 pi. It adds another pi over 2. And then it adds pi over 4. Because this is 1145 degrees, right? It's basically, this guy is same thing as 11 times 45 degrees. And then when you count that, you must end up right there. When you compute this, I think you get something like 450 plus 45, 400, let me compute very quick. 450 plus 45, what's this equal to? 5, 9, 495 degrees. Okay, so that's what it is. So, all right, so then what that is in degrees, it's 495, so we know that we're at quadrant 2. Okay, cool. So then let's figure out the reference angle. So the way we find the reference angle is we find the coterminal angle for this guy. Let me use a different color for this. The coterminal must be this guy, right? So then you might be asking, how do you find the coterminal here? The way we can do that is there's multiple ways. So because we know that this angle is pi over 4, so it's going to be like 1 pi over 4, 2 pi over 4, which is pi over 2, and then 3 pi over 4. So that red angle must be 3 pi over 4 because I'm kind of counting 45 degrees. I have 345 degrees. All right, so I'm at 3 pi over 4. So then the reference angle is when I need to subtract from pi. So I need to do pi minus 3 pi over 4. So then you get what? Pi over 4. So that must be my reference angle right there. Okay. So what do we do with that? We need to compute cosecant. So let's do that on the next page. So we need to compute cosecant 11 pi over 4. Let's think about cosecant, whether cosecant is positive or negative at the quadrant 2. So we know that cosecant is 1 over sine, right? Let me go back to the table and then show you. Where's the table? So we know that cosecant is 1 over sine. So I need to take a look at sine. And in quadrant 2, we know that sine of 45 is square root of 3 over 2. And you guys realize in quadrant 2, sine is always positive. So I have to have positive of that value. Oh, I'm sorry. I need to take a look at 30 degrees. No, wait. Okay, you're right. So pi over 4. So pi over 4 or 45 degrees is what I needed for cosecant because I found that from my reference angle right here. That's my reference angle. I have to evaluate my function for this reference angle. So then I do that, and then I get 1 over sine pi over 2 has to be positive. Again, this is because since sine is positive at quadrant 2. So then 1 over sine pi over 2 is the same thing as 1 over square root of 2 over 2. Flip and multiply 2 over square root of 2. Get rid of the radical in the bottom. The way you do that, multiply by square root of 2, divide by square root of 2. Then you get 2 square root of 2 at the top. Bottom, square root of 2 times square root of 2 is just going to be 2, which is same thing as square root of 2. So that's going to be my answer. So yeah, that's how I find reference angles and evaluate trig functions using my reference angles.